Hello and welcome to Wagner Academy. This is lesson 4.5 for geometry, talking about proving congruence with angle side angle and angle angle side. Now, lesson 4.4 we talked about it with side 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 and side angle side. So a couple of new ways to prove congruent triangles, adding that to our arsenal. So we have these new ideas in this lesson. Make sure you understand those by the time we're done. Make sure you use those extra examples in your book for additional help with any assignments you might have. So let's get started by filling in these two boxes up here. So first off, angle, side, angle. And this one is another postulate. It's a congruence postulate. We'll abbreviate those things like this. This is the third postulate in this chapter, so it's 4.3 for chapter 4, third postulate. And over here we have angle, angle, side, congruence, and this one is actually labeled as a theorem in our book. That means it is provable. We're not going to prove it in this video, but you can prove this theorem based on the other postulates and theorems that we have covered previously in this book. And this is the fifth theorem, so that's why it's 4.5 and not 4.4. This is the third postulate, postulate 4.3. This is theorem 4.5. And these state that in this one, angle, side, angle, we talked about an included angle with side, angle, side. The angle was in between the two sides. Now we have an included side that's in between the two angles. So that's the difference here. So for instance, if I had, this angle, this side, and this angle being congruent over in this triangle to this angle, this side, and this angle, that would be an example of angle, side, angle. And I just noticed I meant to put one mark here, two marks here. That was my fault there. So now these would match up in a corresponding way. So I have angle, side, angle, and angle, side, angle. This is an example of that. What's the difference between angle, side, angle and angle, angle, side? Let's take a look. So over here, it could be something like this, where I could have one arc mark here. I could put a side mark there. I'm going to put two marks here. And then in this triangle, two arc marks here, one tick mark there, one arc mark there. Notice the difference here. Here the side is in between the two angles. It's the included side of those two angles. Over here it's a non-included side. You have the two angles, but you don't have the side in between them being congruent. So this is an example of angle, angle, side. So as you go around a triangle, really you're looking at whatever sides or angles are there. So if you went around this way, you'd have angle and then no side, and an angle and a side. If you went around this way though, you'd have an angle, and then you can't skip two things basically. You can't skip a side and an angle and say this is angle, side, angle. You can skip one thing and say this is angle, like angle, side. So we can skip one thing but not two things. So that's why this is angle, angle, side, and not angle, side, angle. So this one, included angle, or the included side, is in between these. This is going to be a congruent statement for this pair of triangles. Triangle GHI would be congruent to triangle JKL, and you can just verify that this works out. You got two arc marks to none to one. JKL is 2 to none to 1, so yep, that looks like it works out. This would be true by, our abbreviation is just ASA. So angle, side, angle. And this one over here, we would have triangle MNO. Now these may or may not be in alphabetical order. Let's see. MNO, that'd be one arc mark to none to two. So we have to go 1 to none to 2. So this one's not in alphabetical order. So QPR would be the correct corresponding way to match those up. So this would be by angle, angle, side. And again, difference just a quick recap: included side for angle, side, angle, a non-included side for angle, angle, side. And so in this one, I'm going to use a different color for this, just to label that here, that GI and JL are included sides. I suppose if you wanted to make a little note to yourself over here that NO and PR are non-included sides, feel free to do that. I'm just going to say this though for this one. And so this blank down here in a triangle, this side of a triangle that is a side of each of two angles, that would be this one here and this one here. This is a side of each of these two congruent angles, is called the included side with respect to those two angles. So this is the included side with respect to G and I, the included side with respect to J and L. So let's check out some examples now, and we're going to be writing some different types, some different styles of proofs with these examples. So example 1, write a paragraph proof. This is a new idea for us. A paragraph proof, how does that differ from a 2-column and a flow proof? Well, you just write it in a paragraph type form. You just kind of write it in a free-flowing sentence structured type of way. So write a paragraph proof to prove the triangles are congruent. So we have this stuff, this information given to us, and we're trying to prove that these two triangles are congruent. If you've never had eggnog, it's actually pretty good, I think. Personally, I was against trying it for a long time. It just sounded wrong. Eggnog, it just sounds gross, but Christmas time comes around, it's delicious, huh? You should try some if you've never tried some. Just don't drink too much because it's just loaded with calories, unless you're exercising a ton. Lay off the eggnog. Don't drink too much of it. So given that this is true, NO bisects CNG, well, we're writing a paragraph proof. So I'm going to write this in a free-flowing paragraph style. So this is going to tell me something about this triangle. And then angle C is congruent to angle G. That I'm going to label right away in the picture with a normal color. So this is normal color, given information in the picture right there. So I'm going to start by using that. Could I start by saying something about this and then say something about this later? Sure. As long as it's in a logical order, a way that flows logically, that works. So I'm going to start though by saying we are given that angle C is congruent to angle G. Okay, so we started with that. We've got that labeled in our picture. And now we can say something about bisecting is going to tell us something else in this picture. So let's say something like this. So also, since segment NO bisects angle CNG, we can assume that, well, what would that tell us? If it bisects, if NO bisects angle CNG, this whole big angle right here, I'm going to use my different color now. So this is something we can prove is true based on the information. I can say that this angle and this angle are congruent. And labeling that correctly would be CNO and GNO. I could use those as my ways to label these two angles. So I can say that angle CNO is congruent to angle GNO. So that's by the angle bisector definition, or what an angle bisector is. So we have that there. I think our book may call it the angle bisector theorem. So we used that to figure out that this angle would be congruent to this angle. So from there, now we have an angle and an angle. We have an angle and an angle. So it seems like I might be using one of these two over here that I just learned about, angle side angle or angle angle side, to prove that these triangles themselves are actually congruent. So ONC, that's this triangle right here, and then NOG, the NOG triangle, is down here. So can I prove that this side would be congruent to this side? I don't see anything that would let me say that would be true. That would be angle side angle if that were the case, but I don't see that working out here. However, I notice that they share this side in common. They have NO in common. So they would definitely have that side being congruent in both triangles, because something is always congruent to itself. So I could say that this would be the case. So I'm going to say additionally, NO is congruent to itself. So we're actually using the reflexive property. So this is by the reflexive property. Doesn't get used all that often, but in pictures like this, it's a useful property. We can say that something is congruent to itself since it's a segment in both of those triangles. So let's label that then with one tick mark there. So the red stuff was the stuff that I added that I could prove based on what I was given. So I have angle, angle, non-included side, angle, angle, non-included side. Remember, I don't go around this way because I'd be skipping two things. I'd be skipping a side and an angle. So you can only skip one thing at most. Angle, angle, side. So we've got what we need. We've gotten everything that we needed to say to prove that the triangles are congruent. We don't need to prove all 6 parts. We just need to have 3. Either side, 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 angle, or angle, angle, side. We have angle, angle, side, so we can say therefore by angle, angle, side, or AAS, we can say what we're trying to prove is true. ONC is congruent, triangle ONC is congruent to triangle NOG. So moving on to example 2 at this point. We're at a 2-column proof to prove the triangles are congruent. So now we have a 2-column proof format. And I actually want to change this. This will be changed in your notes, but I want to say we're not proving that triangles are congruent. Notice what I have down here. I'm trying to prove that these segments are congruent. So I'm just going to say write a 2-column proof. And I think that's a better way to say that in this one. So that'll be changed in your notes. Don't worry about that. But given this information, that was kind of a hint, though. We are going to have to prove that these triangles are congruent. Well, let's see what I mean by that. Let's get into the problem here. So this is my statements column. And this is my reasons column. So let's start off with what we're given. Could we write a paragraph proof if we wanted to instead, if it didn't specify to write a 2-column proof? Sure. Could we write a flow proof if we wanted to? Sure. This one, though, says to write a 2-column proof, so we'll write a 2-column proof. So OL is congruent to UM. We also are told that angle O is congruent to angle U, and angle L is congruent to angle M. And that reason would be given. So it looks like we have the letters column here. Column. No column. I said column, not golem. Oh, Smeagol's happy that he's not in a geometry problem. Okay, Smeagol. Why don't you scamper around and eat some fish? Number 2, we have that, well, let's label our picture. We're given that this is true. OL is congruent to UM. So I'm going to use my normal color for that. This is given to us. This one is congruent to this one. We're told that angle O, that'd be this one, is congruent to angle U, this one. And angle L is congruent to angle M. This one is congruent to this one. So, looking at that, I've got angle, side, angle, and angle, side, angle. I have congruent triangles. I have nothing else that I have to state that would be necessary to prove those are congruent triangles. However, that's not what I'm trying to prove here, but that would be very helpful to know. So let's write that COL, triangle COL, is congruent to, how would that match up in a corresponding way? COL was no marks to 1 to 2. Let's do the same order there, no marks to 1 to 2. So those triangles are congruent in that way. Col and num. So we have step 2, what was that reason? That's angle, side, angle. And then step 3, well, you might be saying, oh, that's not what I'm trying to prove. How can I prove this now? So OC and UN, are those corresponding sides in these two triangles? They sure are. CO or OC is these first and second letters. UN, that's the first and second letters here. They're supposed to match up. We did this right when we set it up. They matched up in a corresponding way. That means you can say this is true. And what was that reason? It was a 5-letter acronym. Do you remember that acronym? Or you could use 7 letters if you wanted to, but you could say CPOC-TAC instead of CPCTC. But corresponding parts of congruent triangles are congruent. So CPCTC, that would make this true. We proved the triangles themselves were congruent. That means the corresponding parts of those triangles would also be congruent. So that's example 2. And example 3, we're going to do the third style of proof, a flow proof. Oh, Perry the Platypus, it's good to see you. Oh, I see. Heinz Doofenshmirtz, hello, Dr. Doofenshmirtz, welcome from Phineas and Ferb. Perry the Platypus, hello. Write a flow proof to prove the triangles are congruent. So we got Heinz D. We're trying to prove what triangles are congruent here. Well, I see a bunch of different triangles. I'm going to do the same thing with this one. I probably should have left this out, but it's kind of leading us. So let's just say write a flow proof. So I'll fix that in your notes as well. So write a flow proof. We're trying to prove this in the end. HD, this whole side, is congruent to ED, this whole side. So HD, ED, and I'm told, let me write down what I'm told here on the picture, or draw in what I'm told. HZ is congruent to EI. That'd be this whole segment here. So I'm going to put an arc or a tick mark in the middle of that segment. I'm going to put a tick mark in the middle of the segment that it matches up with, EI. And I'm trying to prove this whole thing is congruent to this whole thing here. I'm also told that angle H is congruent to angle E. So I'll put a mark there and there. So it looks like I should use this whole triangle right here with this whole triangle right here. So why don't I use some different colors for this? If you have different colors, it could be useful, I think, in this case. Oh, why don't I go with, I'm going to get crazy here, I'm going to go with purple. Make that, I don't want that big, that's for sure. So this purple triangle right here, I'm trying to prove that this one would be congruent to, and I'll go with green over here, would be congruent to this green triangle right here. Now you might ask, why would that be useful? Well, if I proved that this triangle was congruent to this one, the purple to the green, then I would have these corresponding parts, HD and ED in these two triangles. I could use CPCTC to prove that the corresponding sides, those corresponding sides are congruent. So I've got an angle and a side. I've got here an angle and a side that match up. So I either need another side or another angle. I could use side angle side, or maybe angle angle side, or angle side angle. So I can't prove that angle Z is congruent to, or angle NZD, a better way to say that, would be congruent to angle NID. I don't see any way that would, or anything that would tell me that that would be true. However, I notice, they share this angle right here in common. So I'm going to add that in red right here. So I'm going to put 2 marks in red right there. So I have 2 arc marks. Let me make those arc marks a little better. Let's see if I can do that. So 2 arc marks right here. Yeah, that's better. And this is a flow proof, so we're putting in those boxes, and then we're going to flow things together. So I have this stuff given. I have HZ is congruent to EI. And that's given. I also am told that angle H is congruent to angle E, also given. And I can state, or I can see there, that angle D is congruent to itself, angle D, and it shares that angle in both triangles. So this is another time where we can use the reflexive property. If they share a side or they share an angle, you can say the reflexive property allows you to say that those things are congruent in both triangles. So I've got these three reasons. This would be in red here. I'm going to add some helpful stuff off to the side here. This would be a side, this would be an angle, and this would be an angle. So I have either angle side angle or angle angle side. I got to look and see how they are in this picture. So remember, can't skip two things. If I went this direction, I would be having angle side, and then I'd miss an angle and then I'd miss a side. Can't go that way. I have angle. I can start here at the red, angle, skip that side, angle side. It's not an included side. If it was this one, then I would say angle side angle, but it's this one over here, so this is angle angle side, matching with angle angle side in this one. So this is angle angle side. I can bring these three ideas together, flow them together to say that triangle HDZ, so that was 1 mark to 2 to none, HDZ would be congruent to 1 mark to 2 to none, EDI, triangle EDI. So I just proved that the purple and green triangles were congruent by angle, angle, side, and then from there I can flow that idea to the last thing I'm trying to prove here. HD would be then congruent to ED, so that's this whole length here to this whole length here. Those are now corresponding parts of these triangles that we proved to be congruent. So this is corresponding parts of congruent triangles are congruent, or more succinctly, CP, CT, C. So that proves what we're trying to prove there. Dr. Doofenshmirtz, thanks for making a guest appearance. Gollum, another guest appearance. Make sure you understand how to do paragraph proofs, 2-column proofs, flow proofs with questions like these. Make sure you understand we have 4 things at this point. We have side angle side and side 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 from before. Now we also have angle side angle and angle angle side. 4 different ways to prove congruent triangles. There's actually one more called HL, which we'll get to later. But there's 5 major ways. We've learned 4 of the 5. And other than that, I think that's all I got for now. Yeah. That was lesson 4.5. Have a great day, and I'll see you for lesson 4.6.